We have some examples with vectors. Let's consider their solutions. How to find the coordinates of the vector AB if we know the coordinates of the initial and terminal points of the vector AB. From the coordinates of the terminal point of the given vector, -3, -1, 1, we subtract the coordinates of the initial point, 1, -4, and 5. So we'll have vector AB with the coordinates -3, -1 is -4, it is the first coordinate, -1 plus 4, it is 3, 1 minus 5, -4. It's our answer for the first example. If the coordinates of the vector A are given ax, ay, az, then the length of the vector A, or absolute value of the vector A, it is square root of the sum of squares of the corresponding coordinates of the given vector. So, absolute value of the vector A, it will be 2 squared plus 4 squared plus -4 squared. So we have 2 squared is 4 plus 4 squared, 16 plus -4 squared, it is 16. So we have 32 and 4, 36. Square root of 36, it is 6. We have found the length of the vector A. It is 6 units. Let's consider the vector A with the initial point in the origin, and let the angle between the vector A and positive direction of x-axis be alpha, and the angle between vector A and positive direction of the y-axis be beta, and angle between vector A and positive direction of z-axis gamma. The angles alpha, beta, gamma are direction angles of the given vector A, and cosines of the direction angles, cosine of alpha, cosine of beta, and cosine of gamma are direction cosines of the vector A. How to find cosine of alpha? We should take the first coordinate of the vector A, ax, and we divide by the length of the vector A. Cosine beta equals to the second coordinate of the vector A divided by the length of the vector A, and cosine gamma, it is the third coordinate az divided by the absolute value of the vector A. So we have the absolute value of the vector A, we have found it is 6. So cosine of alpha, it is the first coordinate, 2 divided by 6. Cosine of beta, it is the second coordinate, 4 divided by 6. And cosine of gamma, it is the third coordinate, -4 divided by 6. So we have cosine of alpha, it's 1/3, cosine of beta, 2/3, and cosine of gamma, -2/3. How to find the unit vector E in the direction of the vector A? The length of the unit vector equals 1. So, how to find the coordinates of the vector E? Vector E will be the vector with the coordinates. The first coordinate of the vector A we must divide by the absolute value of the vector A. the second coordinate of the vector E? It is the second coordinate of the vector A divided by the length of the vector A. And the third coordinate A sub z divided by modulus of A. We can see that the coordinates of the vector E are direction cosines of the vector A. So vector E has the coordinates cosine of alpha, cosine of beta, cosine of gamma. So the vector E has the coordinates 1 over 3, 2 over 3, and minus 2 over 3. The standard unit vectors, it's vectors I with the coordinates 1, 0, 0, j, 0, 1, 0, and the vector k with the coordinates 0, 0, 1. In three-dimensional space x, y, z, vector I, it's the unit vector in the direction of the x-axis, j, it's the unit vector in the direction of y-axis, and vector k in the direction of the z-axis. Look, any vector A with the coordinates a sub x, a sub y, a sub z, we can rewrite in the form a sub x multiplied by 1, 0, 0 plus a sub y multiplied by the vector with the coordinates 0, 1, 0 plus a sub z with the coordinates 0, 0, 1. So vector A we can rewrite in the form a sub x multiplied by vector I plus a sub y multiplied by the vector j and plus a sub z multiplied by the vector k. In our example, we have the vector with coordinates 2, 4, minus 4. So the given vector we can express in the form 2 multiplied by I plus 4 multiplied by j and minus 4 multiplied by k. It is expression of the given vector A in terms of standard unit vectors. Vectors lying on the parallel straight lines, vector A and vector B, A and vector C, or lying on the one and the same straight line, vectors lying on the parallel straight lines, or vectors lying on the one and the same straight line are called collinear. The vectors A and B have opposite directions, and vectors C and D have the same direction. Two vectors A and B are collinear if there exists number n such that the vector B equals n multiplied by vector A. If the number n is positive, then the vectors A and B have the same direction. If n is negative, we have the opposite directions. Its equality we can rewrite in the coordinate form. Let the vector B with the coordinates bx, by, bz, and the vector A with the coordinates ax, ay, az. Then, instead the vectors A and B, we can put their corresponding coordinates. The first coordinates the second coordinates and the third coordinates. From each equation we can find n. N from here will be b sub x divided by a sub x. From here n is b sub y divided by a sub y, and from here we have b sub z divided by a sub z. So we have two vectors are collinear if relations of their corresponding coordinates are equal, and it's equals to the number n, which can be positive or negative. Look, the coordinates of first two vectors are non-zero, so let's consider the relations of their corresponding coordinates. 8 divided by -2 equals to -4 divided by 1 equals to -12 divided by 3. We can see that it is correct equalities, so we have collinear vectors A and B. We can see that n is negative, it is -4, so the vector B equals -4 multiplied by the vector A. We can see that if we multiply each coordinate of the vector A by -4, we'll have the coordinates of the vector B. So vectors A and B have opposite directions. The first coordinate of the vectors C, D and M is 0. Let's consider the second coordinates of the vectors C and D. The second coordinate of the vector D, let's divide by the second coordinates of the vector C. 10 divided by 5, it is 2. So let's multiply number 2 by vector C. So each coordinate of the vector C we multiply by number 2. 0 multiplied by 2, it is 0. 5 multiplied by 2 it is 10. 2 multiplied by 2, it is 4. We can see that it is vector, but it is not vector D. So vectors C and D are not collinear. Now let's consider the vectors C and M. If we divide the second coordinate of the vector M by the second coordinate of the vector C, we'll have 3, it's number n, and if we'll multiply that number n by each coordinate of the vector C, we'll have 3 multiplied by 0, 5, 2. We'll have the vector with the coordinates 0, 15 and 6. It is vector M. So there exists number 3 multiplied by vector C. We'll have the vector M. What does it mean? It means that vector M and vector C are collinear, and number n is positive, so they have the same direction. The vectors A, B and C are given in terms of standard unit vectors I, J, K. So we know the coordinates of the vector A, 1, -2, 1. I take the coefficients from that expression. Vector B with the coordinates 1, 1, 1. And what about vector C? The expression of the vector C does not contain vector I. What does it mean? It means that vector I we can take with the coefficient 0. So the coordinates of the vector C are 0, -3, 5. Vectors lie on the same plane or parallel to the same plane are called coplanar. If the scalar triple product of the vectors a, b, c equals 0, then the given vectors are coplanar. If the scalar triple product is positive, then a, b, and c is a right-handed triple. If the scalar triple product is negative, then vectors a, b, and c is a left-handed triple. Let's find the scalar triple product of the vectors a, b, and c. We know the coordinates of that vectors, so it will be the determinant of the third order in the first row, the coordinates of the first vector, the second row, the coordinates of the second vector, and the third row, 0, minus 3, 5, the coordinates of the third vector. Let's make zeros under the main diagonal, and we'll have the triangular form of that determinant. The elements of the first row we rewrite, and let's transform the elements of the second row. From the elements of the second row, we subtract the elements of the first row, and we'll have the first element 0. Then 1 minus minus, so plus 2, it will be 3, and 1 minus 1 is 0. Let's rewrite the elements of the third row. Now let's rewrite the elements of the first and of the second row, and then to the elements of the third row, let's add the elements of the second row. 0 plus 0, it is 0, minus 3 plus 3, it is 0, 5 plus 0, it is 5. So under the main diagonal we have zeros, so it is triangular form of that determinant, and it's equals to the product of the elements of the main diagonal. We have 15, and it is not 0, so the given vectors a, b, and c are not coplanar, but it is positive number, so we have right-handed triple. So we have solved the first 7 examples, and next time we'll consider remaining examples. Best wishes for all. Thank you very much.